The night sky is a brilliant lie. We gaze up at a few thousand visible stars, but the true cosmic population remains almost entirely hidden from view. What if the universe's most incredible stars are the ones we can never see? This is the world of hidden stars, celestial objects that definitively exist yet are completely invisible to our eyes and often to our most powerful telescopes. By the end of this journey, you will know about 30 of these unseen suns, from ghostly stellar remnants to theoretical giants powered by dark matter. We will uncover stars flung from their galaxies and others cloaked within the hearts of black holes. Which of these cosmic phantoms do you think holds the greatest secret? Our cosmic census misses entire categories of stars, beginning with the ultimate exiles. Drifting through the profound emptiness between galaxies are stellar runaways cast out from their celestial homes. These are rogue stars, solitary suns on an endless journey through the intergalactic void. Their isolation is what renders them invisible. Imagine a single light bulb lost in the expanse of an entire continent. Even if it were blazing brightly, you would never see its glow from space. That is the fate of a rogue star, separated from its galactic family by millions of light years of nothingness. The very emptiness that makes them so difficult to detect is also what defines their lonely existence. What kind of cosmic violence could possibly hurl a star clear out of its own galaxy? The leading theory points to the immense gravitational forces at play when two galaxies collide. During this chaotic merger, stars can be whipped around like gravitational slingshots flung out at tremendous speeds. Another possibility involves a star wandering too close to the supermassive black hole at a galaxy's heart, receiving a catastrophic kick that sends it flying into the abyss. These stellar orphans carry with them the story of their violent birth, a permanent record of a cataclysm written in their motion, forever receding into the darkness. Even more elusive than the stellar exiles are suns built from a substance we cannot touch or see. This is the dark matter star, a hypothetical giant that defies everything we know about stellar life. Unlike our own sun, which shines through the violent process of nuclear fusion at its core, a dark matter star would draw its energy from the annihilation of exotic particles. Imagine a power source so alien that it produces almost no conventional light. The star would not blaze with the familiar yellow-white intensity we associate with suns. Instead, it might emit a faint, otherworldly glow of exotic radiation, or remain almost completely dark, a massive shadow against the deeper black of space. Its immense structure would be puffy and diffuse, a wispy colossus potentially larger than our entire solar system, yet nearly undetectable to our telescopes. The very material that powers it, dark matter, is the universe's most famous ghost, felt only through its gravitational pull. Scientists theorize that in the early universe, vast clouds of dark matter could have collapsed under their own gravity, trapping normal matter to form these bizarre, invisible objects. The hunt for them is a frontier of modern astrophysics, a debate that pits bold new ideas against our established understanding of stars. Could these phantom giants be lurking in the cosmic shadows, hiding in plain sight, their true nature masked by darkness? The scale of these cosmic phantoms defies belief. Before the first galaxies had fully formed, the universe may have spawned a star so colossal it makes our sun look like a speck of dust. This is the quasi-star, a hypothetical leviathan from the dawn of time, powered by a monster lurking in its own heart. A quasi-star would begin as a cloud of primordial gas hundreds of times more massive than any star today. Its core would burn so furiously hot and under such immense pressure that it would not just fuse atoms, it would collapse directly into a black hole. Imagine a star that does not simply have a core of fiery plasma, but instead contains a newborn black hole right at its center. This is not a star being consumed by a black hole from the outside. This is a star that has grown a black hole as its own engine. The star's own incredible gravity would funnel a river of gas directly into this central black hole. As the gas spiraled inward, it would release a torrent of energy through friction and heat, an outpouring of radiation so intense that it would push outward against the star's own crushing weight. This delicate, violent balance is what would keep the star from immediately collapsing in on itself. Its structure would be a vast, churning sphere of gas with a tiny, dense black hole blazing like a furnace at its core, holding the entire star up from the inside. For a few million years, this bizarre object would shine, not from nuclear fusion like a normal star, but from the raw gravitational power of its black hole heart. It would be a brief, brilliant candle in the cosmic dark, a beacon we can now only recreate in computer simulations. Its end would be as spectacular as its birth. Eventually, the black hole would devour so much of the star's inner material that the outward pressure would falter. The entire structure, thousands of times the mass of our Sun, would then implode, vanishing from the visible universe and leaving behind only a more massive black hole as its tombstone. We will never see a quasi-star. Their time has long since passed, their fuel spent when the universe was young. They remain one of the most magnificent hidden stars, theoretical titans whose brief, brilliant lives helped shape the cosmos we see today. The echoes of those first quasi-stars rippled through the cosmos, but they were not the true originals. They were preceded by the universe's very first generation of suns, stars so ancient and pure we call them population 3. These were the pioneers, formed from a pristine soup of only hydrogen and helium, the two elements forged in the Big Bang itself. Their existence is one of the most important theories in cosmology, and yet we are certain we will never lay eyes on a single one. They are hidden not by distance or darkness, but by the ultimate curtain of time. They lived fast and died young, burning through their nuclear fuel in only a few million years, a cosmic blink of an eye. Their ferocious energy output, which blasted the early universe with intense ultraviolet light, has been stretched and stretched by the expanding cosmos over billions of years. That once powerful starlight has been redshifted into the faint, invisible whispers of infrared radiation, lost in the background hum of the universe. So why are they so crucial if they are gone? Because these first stars were the universe's original factories, the ones that forged the very building blocks of everything that followed. Inside their searing cores, nuclear fusion created the first heavier elements like carbon and oxygen. Then, in violent supernova explosions, they scattered these newly minted atoms across the cosmos, seeding the gas clouds that would eventually form the second generation of stars, the ones that could then form planets and ultimately life. You are literally made of the stardust forged in those first invisible suns. Every atom of iron in your blood and calcium in your bones was once part of a star that lived and died long before our Sun was even a glimmer in a nebula. The legacy of those first stars was a universe now seeded with heavier elements, setting the stage for stellar oddities beyond comprehension. One of the most bizarre is the Thorn-Zitkow object. This theoretical monster is not one star, but two locked in a final, intimate embrace. Picture a vast, bloated red supergiant star, so huge that it could easily swallow our entire solar system out to the orbit of Jupiter. Now imagine that instead of a core of fused helium and carbon, this giant contains an entire neutron star. A neutron star is the incredibly dense, city-sized corpse of a star that went supernova, packing more mass than our Sun into a sphere just a few miles across. In a Thorn-Zitkow object, this ultra-dense remnant does not orbit the giant. It has plunged deep into the giant's heart, replacing its core entirely. From the outside, this object might look almost like any other red supergiant, a cool, dim, and enormous star. Its hidden nature lies within, where the physics becomes truly alien. The neutron star core acts like a cosmic blender, churning the supergiant's inner layers and powering bizarre nuclear reactions. Unlike a normal star that fuses elements in shells around its core, the Thorn-Zitkow object's unique environment is thought to produce exotic, heavy elements like rubidium, lithium, and molybdenum. These elements would be carried to the surface by the star's churning convection, creating a chemical fingerprint in its outer atmosphere that is utterly unique. This is how astronomers hope to find one, by scanning the skies for a star that looks normal but has the wrong ingredients. The formation of such an object is a story of cosmic violence. It likely begins with a close binary system, two stars orbiting one another. When the more massive one explodes as a supernova, it can kick its newly formed neutron star core into a wild, skewed orbit. If conditions are just right, this neutron star will spiral inward, eventually being swallowed by its gigantic companion. The search for a confirmed Thorn-Zitkow object continues, a hunt for a stellar phantom hiding in plain sight, its true identity written in a secret code of elements that only our most powerful telescopes can hope to read. Even the most enduring stars are not eternal, and their final state is a cosmic relic we have yet to witness. A black dwarf is the ultimate end of a star like our Sun, a cold, dark crystal of carbon and oxygen drifting in the void. It begins as a white dwarf, the Earth-sized ember left after a star gently sheds its outer layers. For trillions of years, this white dwarf slowly cools, radiating its remaining heat into the frigid darkness of space. The journey to becoming a black dwarf is one of fading light and diminishing warmth, a gradual transition from a faint glow to absolute zero. Eventually, it stops emitting any light or heat whatsoever. It becomes a perfect pitch-black sphere, a ghost of a star that once was. The universe, however, is far too young for this process to be complete. The oldest white dwarfs we can observe are still glowing at thousands of degrees. They have not had the time, the countless eons required, to cool into this final, dark state. So a black dwarf is a hidden star in a unique way. It is a certainty of physics, an inevitable future for countless suns, but one that has not yet arrived. It is a phantom from the future, a prediction of the ultimate cold and quiet that will one day claim most stars. When you look at a star like our Sun, you are looking at an object destined to become a black dwarf, a cold, silent tombstone marking a system that was once filled with light and life. This cosmic quiet is still billions upon billions of years away, a final chapter in the life of stars that has not yet been written. But not all cosmic phantoms are the remains of dead or dying stars. Some are the very fabric from which new suns are born. Drifting through the spiral arms of our galaxy are immense, wispy clouds known as infrared cirrus. These are not single points of light, but sprawling, complex structures of interstellar dust and cold gas, stretching for dozens of light years. From our optical perspective, these regions are often just empty black space, voids in the starry tapestry. Their secret is their temperature. They are so profoundly cold, just a few tens of degrees above absolute zero, that they emit no visible light of their own. Instead, they are warmed ever so slightly by the faint, collective glow of the entire galaxy, the diffuse light from billions of distant stars. This gentle heating causes them to radiate a whisper of energy in the far infrared part of the spectrum, a light our eyes are completely blind to. To reveal their true form, we must use telescopes like the Spitzer Space Telescope or the James Webb Space Telescope, instruments designed to see this specific cold glow. When we do, the empty voids vanish, replaced by intricate filamentary structures that look like ghostly mare's tails or delicate cirrus clouds painted across the celestial sphere. These filaments are the raw material for future star systems, the nurseries where gravity will one day coalesce gas and dust into new suns and planets. So when you look up at a seemingly dark patch of sky, you are not looking at nothing. You are gazing at a cosmic cradle, a hidden architecture of creation, silently waiting in the cold and the dark for its moment to begin. The cosmic cradle of infrared Sirius is a promise of future suns, but what about the stars that never truly lit at all? These are the brown dwarfs, the universe's failed stars, objects caught in a perpetual twilight. They form like stars from collapsing clouds of gas, but they simply do not have enough mass to ignite the sustained nuclear fusion that powers a true star. They are cosmic embers glowing faintly with the leftover heat from their birth, and over billions of years they cool and fade into near invisibility. Now consider the possibility that one of these dark, wandering objects is not in some distant star cluster, but right here in our own solar system's backyard. The theoretical Oort cloud is a vast spherical shell of icy planetesimals surrounding our Sun, a remnant of the solar system's formation that stretches nearly halfway to the next star. What if a solitary brown dwarf, a cold, dark giant several times the mass of Jupiter, has been orbiting silently in that unimaginable distance for billions of years? This is not just science fiction. For years, astronomers have been puzzled by the strange, clustered orbits of some small, distant objects in the Kuiper belt beyond Neptune. The gravitational influence of an unseen, massive object nicknamed Planet 9 could explain these peculiar paths. One compelling theory suggests this perturbing mass is not a planet at all, but a free-floating brown dwarf that was captured by the Sun's gravity long ago. The evidence for its existence is purely gravitational, a ghostly signature written in the paths of icy worlds. The evidence against it is its profound silence. A brown dwarf that old, lurking in the Oort cloud, would have cooled to a temperature only slightly above the cosmic background radiation. It would emit no visible light and only a whisper of infrared, making it virtually undetectable with our current technology. It would be a truly hidden neighbor, a dark, frozen sentinel at the edge of our celestial home, its presence felt only through the subtle tug it exerts on the frozen outskirts of our solar system. The thought is both haunting and thrilling that a failed star, a cosmic phantom, could be our most distant and mysterious planetary companion. Cosmic trickery can hide a star in plain sight by amplifying its light 1,000-fold. This is the gravitationally lensed star, a distant sun made visible only because a massive object lies perfectly between it and us. The phenomenon relies on Einstein's theory of relativity, which tells us that mass warps the fabric of space-time. A huge concentration of mass, like a galaxy cluster, acts as a natural lens, bending the very paths that light rays travel along. When a background star aligns precisely behind this cosmic lens, its light is not merely bent. It is magnified, smeared, and often duplicated. We might see multiple distorted images of the same single star, arranged in a perfect cross or a stretched-out arc around the lensing cluster. Without this natural telescope, the star would be an utterly insignificant speck, far too faint for any instrument to detect. Gravitational lensing pulls it from the depths of obscurity, if only for a while. The most famous example is a blue supergiant nicknamed Icarus, whose light was magnified over 2,000 times by a foreground galaxy cluster. For a brief moment, we witnessed a single, ordinary star from when the universe was only about a third of its current age, an observation that would have been utterly impossible without this celestial alignment. These events are fleeting. As the universe expands and the cosmic alignment shifts, the magnified image fades, and the star vanishes once more into the impenetrable dark, hidden again by distance. It is a cosmic magic trick, a temporary glimpse of a star whose true home is the realm of the permanently unseen. Deep within the billowing clouds of a stellar nursery, new stars are being born in total seclusion. These are not rogue stars exiled to the void, but infant suns hidden in the deepest, most opaque wombs the cosmos provides. Places like the famous pillars of creation are not just beautiful cosmic sculptures. They are dense, towering columns of cold gas and dust so thick they completely blot out the visible light from the stars forming inside. From our perspective, These regions are majestic, dark silhouettes against a brighter background. But the heart of each pillar is a chaotic construction site, where gravity is pulling together massive knots of material that will one day ignite as brilliant new stars. For now, however, those stellar newborns are utterly invisible to our eyes. They are buried under layers of cosmic raw material, their brilliant light absorbed and scattered by the very dust that gave them life. It is like trying to see a light bulb through a mountain of thick, black felt. The photons of visible light, the kind our eyes can see, simply cannot escape. So how do we know they are there at all? We must change our way of seeing by observing these nebulae in infrared light, a wavelength that can pierce through the dust like a warm knife through butter. The entire scene transforms. The dark pillars become semi-transparent, revealing the dazzling jewels nestled within. Dozens of brilliant points of light appear where once there was only darkness. These are the protostars and young stellar objects, blazing in the infrared as they radiate the intense heat from their gravitational collapse. The Cocoon Nebula is another perfect example. In a visible light image, it appears as a faint, hazy patch with a single bright star. Switch to an infrared view, and the nebula's core erupts with a rich cluster of young, hot stars that were completely masked by the dust. These hidden stellar nurseries are a powerful reminder that the cosmos is filled with light our eyes are not built to see, and that some of the universe's most active, vibrant places appear to us as nothing more than silent, dark shadows. Even the most steadfast stars are not as constant as they seem. Far from the hidden nurseries of newborn suns, elderly stars perform a slow, rhythmic dance of light and shadow. These are the Mera variables, a class of pulsating red giants whose very nature is to vanish and reappear in our sky. Named for the star Mera in the constellation Cetus, the wonderful, these stars are anything but steady. Over periods that can last many months or even years, a Mera variable will undergo a breathtaking transformation. It swells in size, growing brighter and hotter until it can shine as a prominent beacon. Then, just as steadily, it begins to fade. Its outer layers contract and cool, and its luminosity plummets, often dipping so low that it becomes completely invisible to anyone gazing up without a telescope. For the vast majority of its long cycle, a star like Mera is effectively hidden from casual view, a faint ember waiting for its next command to blaze. This regular pulsation is a sign of stellar old age, a delicate and unstable balance in the star's final stages of life. The star's interior acts like a massive heat engine. As it accumulates energy, the outer layers expand, but this expansion causes them to cool and become more transparent, allowing trapped radiation to escape. With that energy lost, the layers then fall back inward under the star's immense gravity, only to be heated and compressed once more, starting the cycle again. It is a cosmic heartbeat measured not in seconds but in seasons. This makes them celestial lighthouses with incredibly long periods of darkness. For most of the year, their patch of sky appears ordinary, perhaps even missing a star that was there before. Then, slowly, a new point of light swells into view, a familiar ghost returning to its post before beginning its slow retreat back into the gloom. This predictable rhythm makes them invaluable to astronomers, not for what they constantly show, but for what they periodically reveal and then conceal. They are a reminder that the cosmos is alive with cycles, and that sometimes hiding is just part of the dance. Our own sun is a solitary ruler of its planetary domain, but this is a cosmic rarity. Most stars in the galaxy are born in pairs or small groups, creating celestial environments where light itself can become a weapon of concealment. Imagine a distant solar system where two suns hang in the sky, one a brilliant, blazing giant and the other a dim, cool ember. From our vantage point millions of light years away, the faint glow of that second star is completely washed out by the overwhelming glare of its brilliant sibling. This is the hidden host star of a binary system, a sun that may hold planets in a stable orbit, yet remains nearly invisible to our telescopes. The challenge of finding these stellar ghosts is immense. Our most common method for detecting exoplanets involves watching for the subtle dimming of a star's light as a planet passes in front of it. But if the star we are monitoring is actually two stars and the one hosting the planet is the one we cannot see, the entire signal becomes a tangled mess. The dimming might be shallow, erratic, or simply lost in the constant, bright light of the visible star. Astronomers have to become cosmic detectives, untangling the combined light of the system to find the spectral signature of the faint, hidden partner. A real-world example is the star system Alpha Centauri, our closest stellar neighbor. We see it as two bright stars, Alpha Centauri A and B, orbiting each other. But there is a third member of this family, Proxima Centauri, a tiny, faint red dwarf that orbits the pair far out. For a long time, Proxima was overlooked, a hidden star in a system we thought we knew. It was only through meticulous observation that its identity was confirmed, and it is this faint, hidden star, Proxima, that we now know hosts at least one planet, Proxima b, orbiting within its habitable zone. This reveals a profound truth. The most promising worlds for life might not orbit the brilliant, obvious suns, but their quiet, dim, and hidden siblings. The search for these concealed hosts forces us to look past the brightest lights in the cosmos, to listen for the whispers of worlds orbiting stars we can barely see. The brilliant core of our own galaxy is perhaps the most effective cosmic hiding place of all. Lying in the direction of the constellation Sagittarius, the Milky Way's center is a place of both immense light and profound darkness, a region that actively conceals its own secrets. The primary obstacle is a thick, swirling disk of cosmic dust and gas that spans thousands of light years, absorbing and scattering the visible light from everything behind it. Trying to see a star through this is like trying to peer through a blizzard. But the ultimate blind spot is Sagittarius A star, the supermassive black hole that anchors our entire galaxy. This 4 million solar mass behemoth warps space-time around it, creating a gravitational lens that distorts and redirects the light from any star unfortunate enough to lie directly behind it from our point of view. The region is also a maelstrom of intense radiation from the frenetic activity of countless crowded stars and energetic processes, a background glare that washes out the faint signals from more distant, hidden suns. This means there is an entire sector of our own galaxy, a cone of space extending out from the far side of the core, that is completely and permanently blocked from our view. Every star and every potential planetary system in that vast region is a hidden star, not by its own nature, but because it is trapped in the galaxy's most immense shadow. We can infer their existence through the galaxy's overall structure and rotation, but their individual light will never reach our telescopes. They are the ultimate cosmic neighbors we can never know, their stories forever untold, lost behind the brilliant, chaotic veil of the galactic center. Some stars do not merely wander, they flee. These are the hypervelocity stars, celestial projectiles rocketing out of the Milky Way at speeds so immense they are destined for the eternal void. While the rogue stars we discussed earlier were exiled by galactic collisions, these runners are often given their incredible kick by a single, terrifying engine. The supermassive black hole at the very center of our galaxy. Picture a binary star system, two suns orbiting one another as they drift too close to the gravitational monster known as Sagittarius A star. In a flash of cosmic violence, one star is captured by the black hole's immense pull, while the other is slingshotted away, flung outward at a staggering fraction of the speed of light. This stellar catapult launches it on a one-way trip out of the galaxy. Its velocity is so great, often exceeding 1 million miles per hour, that the collective gravity of every star, every nebula, and every speck of dark matter in the Milky Way cannot hold it back. It becomes a runaway not just from its home cluster, but from the galaxy itself. This incredible speed is precisely what makes it so difficult for us to see. These stars are not just moving fast, they are moving away from us on a trajectory that quickly carries them into the profound and empty darkness between galaxies. Our telescopes have a very short window to spot them before they become lost in the intergalactic background, their light stretched and dimmed by both distance and their own rapid motion. They are like bullets fired into an infinite ocean, vanishing almost the moment they leave the barrel. Only a handful have been tentatively identified, their paths traced backward to that violent origin at the galactic core. Each one we find is a precious clue, a message in a bottle hurled from the most chaotic place in the galaxy, telling a story of a gravitational encounter so extreme it turned a sun into a refugee. Sometimes the very material meant to build new worlds instead conceals the star that gives them life. A young stellar object, still hot from its violent birth, can be entirely shrouded by the dense, rotating disk of gas and dust from which planets are forming. When this disk is tilted perfectly on its edge from our perspective, it presents a dark, vertical bar that completely blocks the central star from our view. In visible light, this system appears as nothing more than a flat, opaque shadow, a cosmic silhouette against the brighter background of its stellar nursery. The star itself is a secret, its light and heat absorbed by the very cradle that birthed it. Yet this is not a story of absence but of transformation. While our eyes see only a dark lane, our infrared and radio telescopes reveal an entirely different scene. The tiny dust grains in the outer regions of the disk, warmed by the hidden star's radiation, glow with a faint thermal light. This creates two bright, elongated lobes on either side of the central dark band, like butterfly wings emerging from a cosmic cocoon. The entire structure resembles a giant celestial hamburger with a dark dust lane sandwiched between two bright bun-like emission regions. A stunning example is HH30, our object in the Orion Nebula. For decades, it was just a peculiar dark streak, but when viewed by the Hubble Space Telescope, its true form was unveiled, a perfect edge on disk with stunning clarity, its central star forever hidden from our direct gaze. These systems are more than just hidden stars, they are active planetary construction sites. The very disk that blocks our view is teeming with the chaotic activity of world building, as dust grains collide and stick together, slowly growing into planetesimals and eventually full-fledged planets. We cannot see the architect, but we can witness the magnificent factory it has built, a silent, spinning monument to a solar system in the making. The most distant star we have ever seen is already gone. Icarus, a brilliant blue supergiant, was observed through a 1 in a billion cosmic alignment, a gravitational lensing event that magnified its ancient light over 2,000 times. Without this natural telescope, a single star at such a staggering distance would be an absolute impossibility to detect. It represents an entire class of stars, not hidden by dust or their own nature, but by the simple, cruel mathematics of cosmic distance. The light that finally reached us from Icarus had been traveling for 9 billion years, meaning this star burned out and died eons before our own sun even began to shine. We witnessed a ghost, a celestial postcard from a universe only about 30% of its current age. The perfect alignment that revealed it was fleeting. As the universe continued its expansion and the foreground galaxy cluster that acted as the lens moved on, the magnified image of Icarus faded. It vanished back into the impenetrable dark, a solitary spark glimpsed for a moment before being swallowed again by the vastness of space. This event underscores a humbling truth. For every Icarus revealed by chance, there are countless trillions of other stars whose light is too faint, too stretched, and too diluted by the expanding cosmos to ever register on our most sensitive instruments. They are the true hidden majority, their combined stories lost to the sheer scale of the universe. Deep within the ancient halo of our galaxy, there exist stellar cities so densely packed they defy comprehension. Globular clusters are spherical swarms of hundreds of thousands of stars, all bound together by gravity. While their outer regions can be resolved into glittering points of light, their cores present a different reality. Here, stars are crammed so closely together that the average distance between them can be less than the span of our own solar system. From our distant vantage point, this central region appears not as a collection of individual suns, but as a single, seething blur of unresolved light, a continuous glow where a million points of light have merged into one. Trying to pick out a single star in that core is like trying to distinguish one specific voice in a roaring stadium. The collective glare is simply too immense. This is the ultimate urban jungle for stars, a place where their very proximity to one another is what renders them hidden. The light we see is a democratic blend, an average of countless different types of stars, from ancient red giants to faint white dwarfs, all contributing to the collective blaze. To uncover the individuals within this stellar metropolis, astronomers must use more than just powerful optics. They employ sophisticated techniques like adaptive optics, which corrects for the blurring of Earth's atmosphere in real time, and meticulous computer algorithms that can statistically separate the blended light of stars. By taking thousands of rapid-fire images and analyzing the subtle, random flickers in brightness, they can sometimes tease apart the signal of one star from its countless neighbors. Each star pulled from that luminous fog is a victory, revealing a sun that has spent billions of years in the most crowded neighborhood in the galaxy, its identity hidden not by darkness but by the sheer, brilliant presence of its community. A star's final performance is often its most spectacular. After a long life as a red giant, a star like our Sun enters a surprisingly brief and frantic phase, a final act that lasts only a few thousand years. This is the post-GB star, a celestial object in rapid transition. Having expelled its outer layers in a series of violent pulses, the star is now shrinking and heating up at an incredible rate. Its exposed core, blazing with ultraviolet light, begins to illuminate the vast, expanding shell of gas it just cast off. Yet, for a critical window of time, the star itself can be completely hidden within its own debris. The very material it ejected now forms a thick, dusty cocoon that shrouds the central star from view. From the outside, we might see only a cool, fading giant, not yet realizing the furnace that is awakening within. The star is caught between two identities, no longer a stable red giant, but not yet the brilliant engine of a planetary nebula. Its swift evolution is what makes it so elusive. We are catching it in a cosmic blink, a fleeting moment where it is actively transforming before our eyes, yet often masked by the consequences of its own actions. The eventual outcome is one of the sky's most beautiful sights. As the central star grows hotter, its intense radiation and a fierce stellar wind push the gas and dust outward, sculpting it into intricate shapes. The cocoon of dust dissipates and the hidden star is revealed in all its hot, blue-white glory, now powerful enough to make the surrounding gas fluoresce with brilliant colors. This is the birth of a planetary nebula. So when you admire images of the Cat's Eye Nebula or the Ring Nebula, you are seeing the end product of this hidden phase. You are witnessing the final, public display of a star that spent its last, most dramatic years of change concealed behind a curtain of its own making. Long before the first true stars ignited, the cosmos may have glowed with a different kind of light. Revisiting the dark matter star, we find a theoretical phantom born in the universe's deepest infancy, a sun that existed without ever burning conventional fuel. Imagine a region of the primordial cosmos so densely packed with dark matter that its own gravitational pull began to collapse. This was not a cloud of hydrogen and helium, but a knot of the universe's most mysterious substance. As this dark matter core contracted, it would have drawn in normal matter, the hydrogen and gas that would form the star's visible body. But here, the physics diverges from any star we know. At the heart of this object, dark matter particles would collide and annihilate each other, releasing a tremendous flood of energy. This annihilation process, not nuclear fusion, would be the star's engine. It would generate a constant outward pressure, preventing the star from collapsing further and halting the very fusion reactions that define a normal star's life. The result would be a bizarre, puffy behemoth, a wispy giant that could swell to the size of our entire solar system. Its light would not be the familiar blaze of a sun, but a cooler, more diffuse glow rich in exotic radiation. This star would not forge heavy elements in its core. It would leave behind no chemical legacy, no stellar ashes scattered by a supernova to seed future generations. When its dark matter fuel was finally depleted, the entire structure would simply and quietly collapse into a black hole, vanishing without a trace. The only fingerprint such a star would leave is a profound absence of evidence, a gap in our cosmic history where a giant once stood but left no conventional story behind. How many of these phantom giants flickered in the dark, shaping the early cosmos with their silent, invisible power before disappearing forever into the shadows from which they came? Our own galaxy is not the only one with a hidden population. Surrounding every spiral galaxy like our Milky Way is a vast spherical halo of ancient stars, a ghostly stellar atmosphere that extends far beyond the familiar spiral arms. This halo is not a bright, concentrated core, but a diffuse cloud of individual suns, each one separated by immense tracts of empty space. From our distant vantage point, the combined light of these lonely stars creates only the faintest possible glow, a luminous mist that is completely washed out by the brilliant, concentrated light of the galaxy's central bulge and disk. Trying to see one of these halo stars in another galaxy is like trying to spot a single, specific firefly hovering over a distant city at night. The city's collective glare drowns out the tiny, solitary spark. Yet these hidden inhabitants are crucial to a galaxy's history. They are the oldest stars in the entire system, relics from the galaxy's violent formation over 10 billion years ago. Many were born in the initial collapse of the primordial gas cloud, while others were ripped from smaller dwarf galaxies that were cannibalized during the galaxy's growth. Their orbits are long and slow, carrying them on immense, looping paths that take them high above and far below the galactic plane. They are the galaxy's fossil record, a silent majority of ancient suns whose individual stories are lost in the collective glare of their bustling modern home. The next time you see an image of the Andromeda Galaxy, remember that its beautiful spiral structure is only part of the story. The true extent of its stellar population, a vast sphere of ancient hidden suns, remains forever invisible to our eyes, a secret kept by the sheer, overwhelming brilliance of its central core. The brilliant chaos of a supernova remnant is the last place you would look for a survivor. When a massive star exhausts its fuel and explodes, it unleashes a blast wave of incandescent gas and radiation that shreds everything in its vicinity. Yet, hidden deep within this expanding cloud of stellar debris, a companion star might still be holding its orbit. This is the ghostly survivor, a sun that once shared its life with a giant, only to have its partner vanish in a cataclysm. The very aftermath that marks its companion's death now serves as its perfect cloak. The remnant glows with the intense energy of the explosion, a brilliant, tangled web of hot gas and dust that outshines any single star trapped inside. From our vantage point, the entire region is a single, complex nebula, a monument to destruction. The light from any surviving star is completely washed out, absorbed and scattered by the luminous, chaotic fog that surrounds it. Astronomers search for these hidden survivors by looking for subtle anomalies in the light of the remnant. A slight asymmetry or a persistent hotspot that suggests a steady source of energy is embedded within the temporary glare of the explosion. Finding one is like hearing a single, steady voice in the roaring aftermath of a bomb blast. The existence of such a star raises profound questions. What was it like to witness that detonation from next door? How did the blast wave and the torrent of radiation strip away its outer layers or radically alter its evolution? This hidden star is more than just a celestial holdout. it is a living witness to one of the universe's most violent events, its story silenced by the very dust of its former companion. Deep within the aging heart of our galaxy, a star breathes its sooty, final breaths. Carbon stars are the universe's smoldering embers, ancient suns that have become factories for one of life's most essential elements. While they are a common sight for astronomers, countless others remain hidden from our view, not by distance but by the very air we breathe. These cool, red giants are so rich in carbon that their outer atmospheres are choked with carbon compounds like soot. This cosmic haze absorbs much of the star's own blue and violet light, leaving only a deep, ruby-red glow to escape into space. For someone with a small telescope in their backyard, many of these stars are simply too faint to spot. Their dim, crimson light is easily lost among the brighter, whiter suns that dominate the night. But there is a greater thief of this crimson light. Earth's own atmosphere acts like a dirty lens, absorbing and scattering the specific red and infrared wavelengths that carbon stars emit most strongly. It is as if these stars are whispering to us, but their message is being muffled by a thick, invisible blanket. To truly hear them, we must rise above this veil. Specialized observatories perched on high mountains, or even better, telescopes in space, are equipped with sensitive infrared detectors designed to cut through the atmospheric interference. They reveal a hidden population of these carbon-rich giants, their true numbers and profound red glow finally emerging from the cosmic static. Each one is a testament to the late stages of stellar life, a star that has dredged up the ash of its own nuclear fusion from deep within its core and is now painting the cosmos with the fundamental ingredient for diamonds, for steel, and for life itself. The night sky is riddled with black holes that are not holes at all. These are the dark nebulae, dense molecular clouds that act as cosmic light traps. Barnard 68 is a perfect example, a seemingly vacant patch in the constellation Ophiuchus that appears as a starless void against the Milky Way's bright backdrop. But this emptiness is an illusion, a celestial sleight of hand performed by cold, dark dust. The cloud is not a hole in space, it is a wall. Its countless microscopic grains of carbon and silicate, coated in a mantle of water ice, are so thick and cold that they absorb virtually all the visible light from the stars that lie behind it. The photons we might have seen are not bent or lensed, they are simply swallowed, their energy converted into a faint, imperceptible warmth within the cloud itself. If you could fly through this nebula, the space around you would be anything but empty. You would be navigating a frigid, pitch-black fog, a place where the dust is so dense it would blot out the entire galaxy, turning the universe into an Inkai, starless prison. Yet, on the far side of this dark curtain, entire fields of stars continue to shine, completely unaware that their light is being stolen before it can ever reach our eyes. These hidden stars are victims of a perfect cosmic alignment, their brilliance silenced by a simple, cold cloud of interstellar soot. This reveals a profound truth about the cosmos. Sometimes the most effective way to hide a star is not with brilliance or distance, but with a simple, silent shroud of absolute darkness. A silent dance of gravity can reveal a star with a monstrous partner. In the depths of space, a seemingly ordinary sun might trace a slow, rhythmic wobble across the sky, an unseen force tugging it from a perfectly straight path. This is the telltale sign of a binary system with a hidden companion, but not one of a faint, dim star. The invisible partner is a stellar corpse, a neutron star or a black hole that emits no light of its own. These systems are cosmic ghosts where the living star is forever bound to the remnant of a dead one. The companion's gravity is so immense it dictates the visible star's motion, yet it remains cloaked in absolute darkness, a phantom presence felt but never seen. The only way we know it is there is by watching the survivor, tracing its wobbling path and calculating the mass of the invisible object pulling the strings. Sometimes the evidence is more violent. If the two objects are close enough, the hidden companion's fierce gravity can begin to steal the outer atmosphere from the visible star. This stolen gas doesn't just vanish. As it spirals down toward the neutron star or black hole, it compresses and heats to millions of degrees, releasing powerful bursts of X-rays. For a brief time, the system becomes an X-ray binary, a beacon in a part of the spectrum our eyes cannot see. But when this accretion stops, when the stellar wind weakens or the orbit widens, the X-rays cease. The black hole or neutron star returns to its dormant state, a perfect predator once more concealed by the void, its presence again reduced to the subtle gravitational wobble of its visible partner. These hidden companions are the transformed hearts of dead stars, their existence a quiet testament to a violent past that forever altered the cosmic dance of a surviving sun. The violence of a star's final century can outshine its own core. Wolf-Rayet stars are stellar behemoths in the midst of a spectacular unraveling, shedding their own mass in a furious, continuous gale. These are not stable giants, but exposed stellar cores blazing at surface temperatures that can exceed 100,000 degrees. Their power comes from a desperate race against time. Having exhausted the hydrogen in their cores, they are now fusing heavier and heavier elements in a final, frantic attempt to stave off gravitational collapse. This furious energy output fuels a stellar wind of such immense power that it literally blows the star apart. The star is not gently shedding its atmosphere, it is catapulting it into space at speeds approaching thousands of kilometers per second, 1,000,000 times stronger than the solar wind from our own sun. This creates a permanent, violent shroud of its own ejected material, a circumstellar nebula of glowing gas that expands outward in a complex, turbulent shell. In many wavelengths of light, especially in the visible spectrum, this brilliant, expanding nebula can be so intense that it completely outshines the tiny, searingly hot star at its heart. We see the magnificent, glowing aftermath of the star's self-destruction, while the actual engine driving the chaos remains hidden within its own brilliant glare. The entire system becomes a cosmic masquerade, where the star's funeral shroud is more prominent than the dying star itself. A famous example is the star Gamma Velorum, one of the brightest points of light in the constellation Vela. To the naked eye, it is a single, unremarkable spark. Through a telescope, its secret is revealed. It is a binary system, and one of those companions is a Wolf-Rayet star, its fierce wind colliding with the wind from its partner to create a vast, intricate nebula that masks the true ferocity of the central object. These stars are the rarest of cosmic phases, a brief and terminal stage for only the most massive suns, a final, brilliant disguise before they end their lives as supernova. This universal fog is the echo of creation itself. The cosmic microwave background radiation is the oldest light we can detect, a faint glow that fills every cubic inch of the cosmos. It is the cooled remnant of the Big Bang's fiery dawn, a thermal imprint from when the universe was just 380,000 years old. This background is not just a fossil, it is a living, pervasive screen that masks the very first population of stars from our sight. After the universe cooled enough for atoms to form and space to become transparent, it entered a period known as the Cosmic Dark Ages. For millions of years, there was no light, only the expanding darkness. Then, the first stars ignited. Their brilliant, ultraviolet radiation began to tear apart the neutral hydrogen atoms that filled the void, a process called reionization. This was the dawn of the first light, the end of the cosmic dark ages, but here lies the ultimate concealment. The light from those pioneering stars has been traveling for over 13 billion years. The universe has expanded so dramatically in that time that the very fabric of space has stretched, and with it the wavelength of that ancient starlight. It has been redshifted, stretched from its original, energetic ultraviolet form all the way down the electromagnetic spectrum into the realm of microwave radiation. This means the specific, individual light from each of those first stars is now perfectly blended into the general, uniform hiss of the cosmic microwave background. They are hidden not behind a cloud of dust, but within the very first light of the universe. Trying to pick out a single one of those first stars is like trying to hear a single, specific raindrop after it has fallen into the ocean. Its unique signature is lost forever, dissolved into the cosmic sea from which it came. This background radiation is the ultimate palimpsest, a foundational layer of light that has overwritten the individual stories of the universe's first suns, preserving their collective energy while erasing their distinct identities from our view. Galaxies typically spin like elegant frisbees, their stars moving in a coordinated disk. But nature has a way of breaking its own rules. In the depths of space, some galaxies wear a crown of stars at a right angle to everything else. These are polar ring galaxies, and they create a perfect hiding place for countless suns. Imagine a classic spiral galaxy, flat and wide, with its bright central bulge. Now picture a second, separate ring of stars, gas, and dust spinning vertically around the galaxy's middle, like a Ferris wheel wrapped around a dinner plate. This perpendicular ring is a cosmic fossil, the remnant of a dramatic gravitational encounter billions of years ago. Most often, a smaller galaxy ventured too close to a larger one. Instead of a full merger, the smaller galaxy was shredded, its stars captured and forced into this strange, upright orbit. From our distant viewpoint, this creates an incredible celestial illusion. If we happen to be looking at such a galaxy edge-on, the vertical ring appears as a faint line slicing directly through the galaxy's bright core. The individual stars within that ring are lost in the combined glare of the main galactic disk. Their light blends together, making it nearly impossible to pick out any single sun. It is a stellar population hidden in plain sight, masked by the very geometry that makes its home so unique. Even from other angles, the ring stars are often mistaken for the galaxy's primary disk or its central bulge. Their unique motion is the only clue to their true identity, a secret revealed only through detailed spectral analysis that shows them whirling around on their perpendicular path. These hidden stars are celestial immigrants forever bound to their new home, yet forever distinguished by the ghostly ring that marks their violent arrival. A neutron star's corpse can be haunted by a ghost of unimaginable power. Deep within the galaxy, stellar remnants known as magnetars sleep for centuries at a time, their true nature locked away in absolute silence. These are the ultimate cosmic dormant volcanoes, the hidden stars with the strongest magnetic fields in the entire universe. A magnetar's magnetic pull is so ferociously strong it could strip the data from every credit card on Earth from halfway across the solar system. Yet for the vast majority of their existence, they emit no light, no radio waves, no signal we can easily detect. They are inert, dark spheres of ultra-dense matter, hiding their cataclysmic potential behind a veil of perfect stillness. What gives them away are their brief, violent tantrums. The intense magnetic fields inside a magnetar create immense stress on its solid crust, a crust harder than any material we know. This stress builds and builds until the entire star experiences a starquake, a seismic event of cosmic proportions. The crust cracks and shifts, releasing a colossal burst of energy in a fraction of a second. In that single moment, a magnetar can outshine every other star in our galaxy combined, unleashing a flare of gamma rays and X-rays that briefly floods the cosmos. Then, just as quickly as it appeared, the fury subsides. The star returns to its dormant state, retreating back into the shadows, its location once again a secret. For everyone we have caught in the act, there could be dozens more sleeping quietly in the dark, their immense power hidden until the moment their crust can no longer contain the strain. They are reminders that some of the universe's most volatile objects are also its most secretive, only revealing their terrifying strength in fleeting, brilliant outbursts. Our own galaxy's brilliant disk creates the largest blind spot in our cosmic vision. Known as the zone of avoidance, this is a wide, obscuring band that wraps around the entire sky, a permanent fog bank composed of the collective gas, dust, and countless stars of the Milky Way's plane. It acts like a towering, celestial mountain range, completely blocking our view of the universe that lies directly behind it. Imagine trying to see the landscape beyond a range of brilliant, sun-drenched hills. The hills themselves are beautiful, but they hide everything on the other side. That is the reality for astronomers looking toward this zone. What is concealed there is not empty space, but countless other galaxies and their trillions of stars, all rendered invisible by the foreground clutter of our own galactic neighborhood. We know these hidden galaxies must exist because the universe is largely uniform, and our maps of the large-scale structure of the cosmos show giant filaments of galaxies stretching across billions of light-years. But when those filaments pass behind the zone of avoidance, they simply vanish from our charts, leaving a blank stripe across our most detailed maps of the cosmos. It is a profound reminder that we are not impartial observers of the universe. We are embedded within it, and our own celestial home actively prevents us from seeing our neighbors. The only way to peer through this veil is to change our vision, to use telescopes that see in radio waves and infrared light, wavelengths that can slice through the obscuring dust. Even then, the view is partial and distorted. Every star and galaxy hidden in this zone is a reminder of the ultimate cosmic irony, that the very source of our own sky's greatest beauty is also the reason for our greatest ignorance. The final hidden star exists only as a whisper in the equations of theoretical physics. A Planck star represents the ultimate cosmic paradox, a potential heart of light beating within the ultimate symbol of darkness, a black hole. Our current understanding suggests that anything crossing a black hole's event horizon is crushed into an infinitely dense point called a singularity, a place where the laws of physics break down completely. But some theories, like loop quantum gravity, propose a different, more elegant fate. They suggest that at the very core of a black hole, matter does not collapse into an infinite point. Instead, it reaches a maximum possible density, a fundamental limit imposed by the quantum structure of space-time itself. At this point, the collapse stops. The result is not a singularity, but an immensely dense, exotic object, a Planck star. This star would be tiny, perhaps only a trillionth of a centimeter across, yet it would contain the entire mass of several suns compressed into that unimaginable speck. It would be a ball of matter so dense that it represents the absolute limit of reality, a place where gravity and quantum forces reach a precarious standoff. This entire structure, however, is forever hidden from our universe. The black hole's event horizon, the point of no return, wraps around it like an impenetrable shield. No light, no information, no signal of any kind can escape from within to tell us about the Planck star's existence. Its brilliant, compact energy is trapped behind the ultimate cosmic curtain, making its reality currently untestable and forever beyond our direct observation. It remains a beautiful mathematical possibility, a secret sun locked in a prison of its own making, challenging our very understanding of where a star ends and a black hole begins. The universe's stellar population is a grand tapestry woven with threads of light and shadow. We have wandered through a gallery of cosmic phantoms, from the dark matter giants of the primordial dawn to the cold, silent black dwarfs of the distant future. We have encountered stars hiding in the brilliant glare of their own funeral shrouds, stars concealed behind walls of interstellar soot, and stellar corpses whose immense power is revealed only in brief, violent tantrums. This incredible diversity reveals a humbling truth. The glittering points we admire on a clear night are the rare exception, not the rule. For every star we can see, there are countless others whose light is stolen, stretched, silenced, or simply lost to the abyss of space and time. The true cosmic landscape is one dominated by the unseen, a reality where most of the action happens just beyond the reach of our senses. This journey does not end here. It merely opens a door to a deeper mystery. What other celestial secrets remain hidden, waiting for a new theory, a sharper telescope, or a fleeting cosmic alignment to reveal them? Which of these 30 hidden stars captured your imagination the most? Was it the lonely rogue star exiled to the void, the theoretical quasi-star with a black hole for a heart, or the phantom sentinel that might be lurking in our own solar system? Share your thoughts in the comments below and let us continue to peer into the darkness together, searching for the next great cosmic secret.